So in the previous video, we noticed that there were a couple of rows and columns that were non-numeric. In this video, we are going to address that. We're going to see what's going on. So we're going to be dealing with cells or columns with unwanted strings within them that are difficult to detect. So the first line of code that I run is always to check the data types when I start an exploratory data analysis. I think it's important to get a view of that. And we can see here, there are clearly issues which we didn't deal with in the earlier video. For example, these numeric columns, such as innings batted, number of runs scored, not outs, highest score, etc., these should not be object columns. But how can they be object columns? In earlier videos, I did scan these columns, and there were no strings or no funny signs. Remember, we removed funny symbols in the data in an earlier video, which you can see up top here. So there's clearly a problem over here. Balls is an object. BBI we would expect to be an object, as well as BBM, because remember, in the BBI and BBM columns, the / indicated and separated the number of the wickets with the number of the runs, respectively. So we would expect object to be there, but not in the other columns that are highlighted over here. So let's then deal with that. Let's try and find out, firstly, what are the numeric columns? And we've done this before in previous code. You see it's listed over there. Let's try and change these columns to float. Why would we do that? My general approach is to use floats, because although you would expect that these columns would not need to be floats, it's always good to cover yourself when you're working with big data sets. You never know if a value has a decimal attached to it. I'm going to convert these numerical columns all to floats. Shift enter. Now notice it says that there is an error. And the error it gives is it cannot convert string to float. And then it gives this over here. This tells me that there's a problem because there's a spacing. Now, you didn't pick it up earlier because we were looking for specific symbols. If you can remember in the earlier video, you can have a look at that up top here. Python picks up a space, a white space, as a string. And that can cause big problems in the way that you are able to analyze as well as visualize your data, because Python will pick up a particular column as a string, or an object in this case now, because there are string values in the cells, but you can't see them. And you can't see them in this case now because it's a white space. So let's now run this line of code. So I'm going to identify the cells that have open spaces, open white space, and then I'm going to ask it to filter in the data frame and show me these specific rows and print it. So the output then provides that over here. You will notice that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 rows that have cells in them where there is a white space that you would not have been able to see with a blind eye. So it's extremely important. If you can recall in the earlier videos, we looked for symbols such as @signs, $signs, hashtags, asterisks. We didn't see the white space. And then it makes sense because in the previous video, we were trying to identify, if we go up here, we were trying to identify the interquartile range, which we couldn't calculate. And there was only one variable that exceeded the threshold for the IQR. But that surely can't be, because in an earlier video, we identified that, for example, Alan Donald's bowling figures for his wickets were regarded as a potential outlier, but it's not shown here. A lot of things are starting to make sense here. A lot of the pre-processing that I've done used so-called numerical columns, but it excluded other numerical columns which we thought were okay, but they weren't because they had the white space. In fact, we didn't even use those columns as numerical columns because they were identified as objects. So now we know why. We need to convert those columns, which we know should be numerical, we need to convert them to numerical. Case in point, these over here. These are all numerical attributes or columns, but they're not listed as that. Now that we have an idea, as we go down the code, we have an idea of the columns that have these white spaces. We can do something about that. So we're going to replace these empty white space cells with a nan. So let's run that. You'll notice it also gives an error. So let's look specifically which columns have these nan values. And if you look over here, you will see, if you go to the top, you'll see that it's balls. Remember, there was a problem in the earlier video with balls. So to average bowl, so to strike rate, so to 5 innings in a match. Let's replace them with a 0. Now you notice it says it cannot do that. Why? Because some of the columns identified are actually categorical. So let's first then replace the numerical columns with nans with zeros. And we identify these that are not categorical. So we run that code. Now we're going to check to print it. And if we do that, you'll notice that some of them have disappeared. Now it's only 5 wickets in innings that seem to have these nan values. So let's identify which of these cricketers have this nan, not a number. Tony Dezorzi and Zubair Hamza. What are we going to do with this? Let's replace these values with a 0 as well, and specifically the 5 wickets in an innings. So we filled with a 0. Now we are going to check for nan values in the entire data frame. You can see that there are no missing values which we assigned. And let's now print the data types. So we have no missing values that was attached to the cells with the open space, but we still have a situation where there are data types that are not numerical. Let's convert these object data types to floats. So I've identified the respective columns over there, and I'm going to convert them to float. So we run the code. You'll see there's an error. Why is there an error? Because again, you cannot convert a string to float and that open space is still there. So now we're going to replace those remaining empty strings with a nan. And then we print. Now you can see that the float values are assigned to specific categories that you would expect. Highest score, however, is still a problem. And I know that the highest score column includes an asterisk next to the number of the highest score if the highest score is a not out. For that reason, the highest score is identified as an object, which is a problem. So what are we going to do now with this highest score? Because someone like A.B. de Villiers has a highest score of 278 not out. If we take away the asterisk, we don't acknowledge the fact that it's a not out. So one way we can do it, and the way that I've selected, is you split the highest score column into a column with a score, and then we create a new column next to it, which indicates whether or not the highest score was not out. So we split the HS column into HS and HSNO, which indicates whether or not the highest score was out or not out. Let's run that code. Let's run the first 5. And you can see then that right at the end, there is an additional column called HS not out. If there is a no, it means the highest score was out. If there is a yes, it means the highest score was not out. So I know, for example, A.B. de Villiers has a highest score of 278 not out. The asterisk is gone. And if you look in that column at the end, there's an indication of a yes. So then we know the highest score of 278 was not out. Great. What we can then do is we reorder the column, because we want that column, HS not out, to be next to the column called HS, so that you can see what the highest score is, and you also know that the highest score was out or not out. What this means is, in the data dictionary, you will have to include a description of the column called HS not out. So let's run the code. Let's run the head, first 5, and we can see that the HS and the HS not out are next to each other, but the problem is Python has now moved it to the beginning of the data frame. You could have specified in this line of code over here specifically where you wanted it to move, but just for reference sake, let's move it back now. So I run this code over here where I index the location where I want the HS and HS not out to move to, and I indicate over there, and I insert HS and HS not out next to each other. Then I'm going to run the data head over here. You can see you have not out, average bat, highest score not out. If it's a yes, it means it's not out. We know that A.B. de Villiers is not out. We know that Ashwell Prince is not out, 162 not out. The columns have now moved, but what happened to the data types? Let's have a look there. If we go and look at the highest score and the highest score not out, the highest score is an object, which is still a problem. And the highest score not out is an object, which is not ideal because we want it to be a categorical variable. So now we're going to convert HS to an integer, and we're going to convert HS not out to a categorical variable. So Shift Enter. Let's print the data types, move it down. So now you have a situation where you have the HS as an integer, the highest score, and the highest score not out, a yes or a no as a categorical variable. So the data now looks like it is much better. Now what this means is very important, because we've done a lot of pre-processing in previous videos where the data has not picked up certain columns as numerical, which means a lot of the conclusions that we could have made earlier in previous videos were not that accurate. So ideally what you should do is you should move all of these lines of code where you have fixed the data types to the section in previous videos where the data types are dealt with, so that you have numerical values for columns that you know are indeed numerical values. Why I did it here instead of earlier is because I want you to realize that the process you follow when analyzing data is not linear. Just as you think that you have finished doing one type of pre-processing, there might be errors in data or problems in data that will cause you to fix it and then redo many of the steps that you've done previously. And this occurs especially with huge, large, very big data sets. We've therefore got a good take on the data right now. It looks a lot better in terms of the categories and the floats and the integers in terms of analysis. If we look at the minimum and maximum values, this will give us a further indication as to the accuracy of the data. If we look at this, there is nothing untoward here. I know the data pretty well from my domain knowledge. I know that the most number of innings batted, Jacques Kallis 278, 165 test matches, 19 years active. You would expect that most of these maximums would be Jacques Kallis's, although the highest score is Hashim Amla's. Most number of hundreds are his. I'm not sure about the zeros, the ducks. When it comes to bowling figures, that will not be Jacques Kallis's, although he is an all-rounder. The most number of wickets would be Dale Steyn, and many of these would apply to Dale Steyn. In terms of the strike rate, you've got the maximum of 192. That's not a good indicator. A lower strike rate is better. You would assign these most 5 wickets in an innings probably to Dale Steyn as well. So a lot of these columns look a lot better in terms of the way that we can interpret them. What I've got over here is I ask Python to list the actual cases or rows where the minimum and maximum values for each respective column are situated. So for example, with regards to the column active years, the minimum cases for active years is 1. And here it lists all the cricketers that played for the Proteas for only 1 year. If you scroll down, remember it lists the entire row. If you scroll down, you will then get to the maximum case for active years. And then you can see Jacques Kallis active years 19. So it does this for every single column. The next column would be matches. The minimum case would be 1. If you scroll down for matches, the maximum case would be Jacques Kallis, 165. So as you scroll down here, it applies to every single column. Now, again, I want to reiterate the fact that many of the analyses we did in previous videos, the conclusions we came to will not be as accurate because the columns in the previous videos were not all numerical. Now we have converted the respective and important columns to numerical columns, which enables us to do a more thorough, more granular analysis of the data with respect to numerical columns. But luckily now, in terms of the order of the videos that we are looking at, as long as we have this correct right now, we can continue with the exploratory data analysis because we have the columns as numerical that should be numerical. And that is the focus of the next video. I'll see you there.